In the stillness of the night sky, the sun has always been our anchor, steady, bright, eternal to the human eye. But imagine, just for a moment, that something small, ancient, and alien has begun to feed upon it. Astronomers call it 3I divided by Atlas, the third interstellar object we have ever seen. To science, it is ice, dust, and motion. Yet in the whispers of speculation, in the language of metaphor and possibility, some call it a parasite, a traveler that drifts into our system not merely to pass by, but to drain, to pull at the sun's lifeblood, one molecule at a time. A cosmic leech against a star billions of times its size. Tonight, we will explore that story carefully, slowly, across 40 quiet chapters, always rooted in what we know, always honest about what we don't, and always carrying the haunting thought, what if the sun itself could be consumed? It began, as many great discoveries do, not with fireworks or alarm, but with a quiet notation in a survey log, a faint dot of light slipping against the background of steady stars, moving just enough to draw the eyes of a patient observer. On July 1st, 2025, the Pan-STARRS telescope in Hawaii flagged an object whose trajectory seemed odd. At first glance, it resembled many of the comets that sweep through our skies, icy visitors whose tails light up our nights. But mathematics whispered otherwise. The orbit was not closed. The curve was not bound. This was something entering from beyond, something that would never return once it departed. The third interstellar visitor humanity has ever seen. Astronomers labeled it 3I divided by Atlas. 3I for the third interstellar object, Atlas for the asteroid terrestrial impact last alert system that first picked it out. Yet, even in those early days, some noticed that this was not a comet in the traditional sense. The brightness, the coma, the chemical signatures, they all seemed strange. Too much carbon dioxide, too little water, a cloud vast beyond expectation. To scientists, these anomalies were data points. To storytellers, they were metaphors. And so the image arose of a parasite, a small alien body that had not come to simply pass, but to feed. The idea of a parasite is unsettling when applied to space. We are used to thinking of parasites in biological terms, leeches on skin, fungi on trees, small creatures drawing sustenance from larger hosts. But here, in the cold void between stars, the scale is inverted. The parasite is small, icy, and insignificant on its own. The host is immense, radiant, the very star that sustains us. And yet the metaphor holds, because 3I divided by Atlas seemed to draw energy, to pull at light, to create the illusion of a star ever so slightly diminished. When astronomers first pointed their instruments, they noticed that the coma of 3I divided by Atlas grew not gradually, but explosively. It was as if the sun's heat had awoken something long dormant, and the object responded by stretching out a veil of gas and dust so large it defied expectation. In mythic terms, the parasite had latched on. The halo of activity became its feeding mouth, wrapping itself in a siphon of solar energy. What made the story even more haunting was the geometry of the encounter. 3I divided by Atlas did not skim gently around the sun like a harmless comet grazing and then fleeing. It cut deeper, closer, into regions where the star's radiation is strongest. Each calculation suggested an intimacy that felt predatory. The small body seemed drawn not just by gravity, but by hunger. Of course, science is careful. Astronomers measure spectra, compare ratios of carbon to water, calculate outgassing rates. They talk of thermal stress, sublimation fronts, volatile chemistry, but the quiet undertone remains. The sun seemed to be giving more than it should, and the object seemed to take. For the human mind, that story resonates on a primal level. The sun has always been our eternal constant, the source of life, the one thing we never imagined could be diminished. To imagine it vulnerable, even if only in metaphor, stirs unease. Could a parasite truly cling to a star? Could something so small weaken something so vast? And yet, nature is full of such imbalances. Small parasites topple great creatures. Microscopic agents change the course of empires. Perhaps the cosmic scale is no different. Perhaps, in some slow, incomprehensible way, even stars can be drained. Thus, the arrival of 3I divided by ATLAS was recorded not only in the annals of astronomy, but in the imagination of those who watched. A traveler from another system, a parasite from the dark, approaching our sun not as a guest, but as a feeder. The first chapter of a story that would leave us wondering whether the light we trust is, after all, unassailable. When an interstellar traveler enters our solar system, its first conversation with the sun is always through heat. Radiation presses against ancient ice, photons strike dust that has slept for billions of years, and the object awakens with a shimmering veil. For most comets, this is routine. Water vapor vents, tails stretch across the sky, and the spectacle follows a familiar script. But with 3I divided by Atlas, the script broke. What scientists saw in those early weeks was not the gentle release of water, the usual signature of a sun-warmed body. Instead, instruments detected an abundance of carbon dioxide, far more than expected, and out of proportion to what our solar comets display. It was as if the parasite had chosen a different pathway to draw sustenance, not sipping at the sun in the way others do, but tapping into a deeper, stranger vein of energy. The coma itself grew vast and unruly. Measurements from ground-based telescopes and spaceborne observatories showed a halo expanding far beyond the scale of the nucleus. The brightness did not simply rise in a smooth curve. It spiked, surged, and swelled, as if the object were gulping at the light. To astronomers, it was an anomaly to model. To the imagination, it was the first visible sign of feeding. In a sense, the sun was offering itself without resistance. Every star emits its energy outward in all directions, a flood of photons and particles that streams across the void. Most of that energy races past planets, dust, and gas without ever being touched. But here, in this small and sudden encounter, a traveler appeared to gather that outflow, to use it not only for heat, but perhaps for something more. Some observers described the coma as a siphon, a translucent mouth stretched wide, drawing solar particles into a shell that would never give them back. The scale was staggering. Tens of thousands of kilometers across, glowing faintly, drifting silently. A feeding halo, and yet the feeding was subtle, almost polite. The sun did not dim by any measure detectable to us. Its output remained steady, its rays still bathed the earth. But in the details, in the chemistry and the shapes, there were whispers. Carbon dioxide vented in ratios that suggested not just sublimation, but selective consumption. Dust patterns hinted at controlled release rather than chaotic collapse. It was as though the parasite had learned to take only what it could carry, careful not to alarm the host. The first signs were also seen in the solar wind. Instruments noted disturbances, faint irregularities in the plasma streams surrounding the object. These could be explained by natural interactions. Yes, but the image persisted. A small mouth drinking from a great river, altering the current ever so slightly. For scientists, the challenge was to hold on to facts while acknowledging the unease. They plotted outgassing curves, compared them with models of solar heating, and debated whether such behavior was truly unprecedented. For storytellers, the conclusion was more visceral. Something had begun to feed. It is worth remembering how the human mind works when faced with the unknown. We project familiar fears onto distant phenomena. We describe comets as omens, supernovae as dragons, eclipses as devourers. The parasite frame is one more entry in that long history, yet it is also rooted in the strangeness of 3I divided by Atlas itself. It behaved in ways our expectations could not comfortably explain, and so the narrative took hold. The sun, eternal giver of life, now cast in the role of reluctant host. The object, small and alien, cast as a cosmic leech. The feeding may be no more than sublimation, no more than chemistry unfolding on a tiny nucleus, but the image is larger, the first signs of a star being drained, however imperceptibly, by something that should have been too small to matter. The first bite had been taken, and humanity, watching from the safety of its blue planet, began to wonder whether the parasite would be content with just a taste. Energy is the one thing the sun has in endless supply. Every second, it pours out more power than all of human civilization has used in its entire history. Photons race outward, trillions upon trillions, filling space with warmth and light. Normally, almost all of that energy simply escapes, unclaimed, drifting forever into the cold of interstellar night. But when 3I divided by Atlas arrived, some of those rays did not vanish into infinity. They were caught. They were drawn into a body no larger than a mountain, wrapped in a shroud of dust and gas, a veil that acted like a net. The process is, on its face, ordinary. Heat strikes frozen surfaces, ices sublimate, gases erupt into the coma. Yet, with Atlas, this ordinary process looked different. The coma did not just reflect sunlight, it seemed to absorb it. Observations showed odd thermal signatures, wavelengths vanishing into the cloud instead of bouncing back. It was as though the parasite had extended an invisible organ, a siphon through which the sun's generosity was captured and consumed. Imagine a single drop of blood leaving a body. On its own, it means nothing, but a steady drip, hour by hour, can weaken even the strongest creature. The sun is not in danger from one comet, nor even from hundreds. Its scales are too vast. Yet the idea that something could draw energy away, even at the smallest level, unsettles the mind. It reframes the sun not as untouchable, but as a host vulnerable, if only in principle, to feeding. The carbon dioxide dominance in Atlas's chemistry makes this picture even sharper. Carbon dioxide molecules absorb and scatter light in distinctive ways, creating heat traps that can funnel energy deeper into the coma. Unlike water vapor, which releases energy quickly, CO2 lingers, holding warmth, making the shroud of the parasite feel like a sponge soaking up sunlight. Scientists debated why this chemistry appeared so skewed. Some suggested that Atlas had formed in a colder, stranger nursery around another star. Others speculated that radiation over billions of years had reshaped its surface. In both cases, the effect was the same. The sun's energy was drawn in, held, and converted into the strange and sudden brightness we saw. It was not just photons being harvested. The solar wind, that ceaseless outflow of charged particles, also bent around the body. Plasma flows disrupted, magnetic ripples formed, and small eddies in the heliosphere marked the place where the sun's breath was caught and turned. Normally, this interaction is negligible, a footnote in the grand system of the heliosphere. But here, the scale of the coma made the effect visible across millions of kilometers. To some, it looked less like interaction and more like ingestion. The question then becomes, where does that energy go? For a comet, the answer is simple. It goes into motion, into venting, into the glow of the coma and the faint push of the tail. But if one lets the metaphor deepen, another answer emerges. The parasite is storing it. The coma is not waste, but harvest. The tail is not discharge, but trace. What we see as dissipation may, in some sense, be accumulation. To frame it in myth, the sun bleeds light and the parasite drinks. To frame it in science, sublimation and plasma drag transfer energy from the star to the object. Both perspectives converge on the same haunting image, the smallest body drawing sustenance from the largest. The brilliance of Atlas's coma was a sign of this transfer. Its size, disproportionate to its nucleus, spoke of a process that went beyond our models. Energy was not simply touching and bouncing. It was being drawn in, captured, and remitted in forms that changed the balance. A parasite does not destroy its host all at once. It takes, slowly, carefully, hidden beneath the appearance of harmony. And so the sun still shone, Earth still basked in its warmth. Life continued as though nothing had changed, but in the details, in the chemistry, the plasma, the light, the quiet act of drawing away had already begun. When a comet or interstellar visitor approaches the sun, its coma, the glowing envelope of dust and gas, is usually just a byproduct of heat. Ices sublimate, gas streams outward, and sunlight reflects from the cloud like a mist caught in a beam of light. But with 3I divided by Atlas, the coma became something more than scenery. It became a structure, vast and luminous, that seemed to function like a feeding halo. From the first images, astronomers noticed how disproportionate it was. The nucleus itself remained hidden, likely no larger than a mountain, yet around it bloomed a sphere hundreds of thousands of kilometers across. To the eye it was faint, but in sensitive instruments it glowed with chemistry not quite like anything seen before. Carbon dioxide dominated, water lagged, and the halo seemed thick in ways models did not predict. If the parasite metaphor had begun as a whisper, here it became louder. The coma looked less like waste and more like a mouth. A feeding halo is not a scientific term, of course. It is a way of imagining what the coma might represent if we stretch the metaphor. Picture the sun's light as a stream of nourishment, spilling outward. Around 3I divided by Atlas, that stream did not simply pass by. It was intercepted, trapped, and reprocessed by the gases that poured from the nucleus. Each molecule of carbon dioxide became a tiny net, catching photons, holding heat, and bending solar energy into forms the object could use. Scientists compared it to a sponge, the coma soaked in radiation, and its sheer volume meant that a surprising fraction of local solar output was being handled by this cloud. Normally, a comet's coma is thin, translucent, easy for light to pierce. But reports suggested that Atlas's halo was denser, its brightness more persistent, and its shape more organized than expected. It was as if the parasite had grown a membrane to shield itself, a translucent organ stretching into space. In plasma studies, further hints appeared. The coma deflected solar wind in wide arcs, creating a bow shock that rippled far beyond the tiny nucleus. This was not unusual for a comet, but the scale here suggested a more active process. In the metaphor of feeding, this halo was not only catching photons, but also filtering the sun's own breath, siphoning particles into its expanding shroud. And there was another detail, more haunting still. The coma did not brighten evenly. Some sectors glowed more than others, hinting at jets or focused regions of activity. To astronomers, this meant venting from specific fractures in the nucleus. To the storyteller's eye, it meant something else. The halo was not passive, but directional. It looked like a parasite adjusting its mouth, focusing its feeding where the flow was richest. Even the tail, that long, ghostly streamer pulled away by sunlight and solar wind, added to the picture. Dust, grains, and gas, stripped from the coma, stretched back as if carrying away fragments of the sun itself. One could almost imagine the parasite not only feeding, but discarding, leaving trails of spent material in its wake. In truth, the sun has not been harmed. Its brilliance is unchanged, its lifespan unthreatened. What we see in 3I divided by Atlas is more likely chemistry and physics, sublimation and scattering. the ordinary work of ice under heat. But the imagery lingers because of scale and contrast. A star is supposed to be untouchable, a blazing titan immune to the hunger of small things. And yet here was an object that, through nothing more than surface chemistry and a halo of gas, seemed to drink from it. The coma became a symbol of vulnerability, of imbalance, of the strange possibility that even a star can be diminished, if only in appearances. A feeding halo, vast and quiet, marking the point where the sun's endless gift met the grasp of something alien. And as Earth watched from a safe distance, telescopes tracing every shimmer, the story of the Parasite deepened. The halo was not just decoration. It was appetite, made visible in the dark. When astronomers first measured the gases escaping from 3I divided by Atlas, the results were surprising. Instead of water vapor dominating, as is typical for comets in our solar system, carbon dioxide emerged as the primary gas. It poured into the coma in quantities that did not match our expectations. To scientists, it was a chemical puzzle. To storytellers, it was an image. Carbon dioxide, acting as the straw through which the parasite drank from the sundae. On Earth, we know carbon dioxide as the invisible gas of our own breath, as the driver of climate change, as a molecule that traps heat. In space, it plays a different role. Frozen solid in the outer reaches of star systems, it remains locked away until warmth sets it free. When the sun's rays struck 3I divided by Atlas, this gas erupted into space, forming not just a haze, but a vast envelope. Unlike water, which sublimates closer to the sun, carbon dioxide can vent strongly even at great distances. That made 3I divided by Atlas active earlier than expected, glowing in places where a normal comet would still have been quiet. The metaphor of the straw fits because of the way carbon dioxide interacts with energy. Each molecule absorbs and re-emits light, particularly in the infrared, trapping heat and passing it around the coma like a network of tiny hands. Imagine the sun's photons as liquid pouring down. Carbon dioxide becomes the tube through which that liquid is sipped, channeling the energy directly into the body of the parasite. This unusual chemistry made the object's halo both brighter and more persistent. It allowed the coma to grow larger than models predicted, extending hundreds of thousands of kilometers into space. From a distance, it appeared as if Atlas had wrapped itself in a great translucent mouth, widening its reach, ensuring that more of the sun's light was intercepted. A feeding structure, invisible but effective, built from the simplest of molecules. Astronomers debated what this meant about Atlas's origins. Perhaps it had formed in a region of its home system where carbon dioxide ice was abundant, beyond the water snow line. Perhaps radiation and collisions over eons had stripped away other volatiles, leaving CO2 as its last reserve. Either way, the effect was the same. The parasite fed through a straw that few other comets carried in such abundance. The CO2 also shaped the parasite's behavior in subtler ways. Because the gas vents earlier, it may have cloaked Atlas long before it reached the inner system, creating the illusion that it was hungrier, more eager than anything we had seen before. By the time telescopes caught it, the straw was already in place, drawing quietly from the stream of solar energy. Even the tail told the story. Jets of carbon dioxide carried dust away in straight, sharp flows, marking the points where the straw connected to the sun's output. In images, these jets looked like channels, like veins, each one a line through which energy was being siphoned. To scientists, they were evidence of fractures in the nucleus. To those who leaned into the metaphor, they were straws reaching out to sip at the star. There is something unsettling about the idea of a straw in space. It suggests intent, focus, direction. Of course, we know 3I divided by Atlas is not alive, not conscious, not truly parasitic. But the CO2 creates the appearance of behavior as if the object had chosen a method, optimized a tool, and placed it carefully into the endless well of solar energy. And so the image persists. The sun as a reservoir blazing with power, and Atlas as a small, patient feeder, sipping through its carbon dioxide straw. Each molecule carried away becomes part of the halo, part of the trail, part of the memory that this star once shared. In that simple chemistry lies the unsettling truth. Sometimes, the smallest molecule can become the perfect instrument of hunger, and sometimes, even a star can feel as though it is being drained. The sun's corona is one of the strangest sights in the solar system. A halo of plasma, hotter than the surface itself, stretching millions of kilometers into space. It is both delicate and fierce. Normally, only during a total solar eclipse can we glimpse its streamers with the naked eye, a shimmering veil of light that speaks of the star's restless energy. For centuries, the corona has seemed untouchable, ethereal, beyond interference. Yet, when 3I divided by Atlas approached, some astronomers began to describe faint disturbances, hints of shadow, across this radiant crown. They did not mean darkness in the literal sense, as if the comet had eclipsed the star. They meant subtle irregularities in the way the corona behaved, ripples in its structure, deviations in brightness, disturbances in the flows of charged particles. To the careful eye, it looked as if the sun's aura had been brushed, disturbed by the presence of something small yet insistent. The parasite metaphor deepens here. If the coma of 3I divided by Atlas is a feeding halo, then the shadows across the corona are the marks of its feeding. Imagine a leech on skin. The host still lives, still functions, but the area around the wound changes. Blood flows differently, pressure shifts, and subtle bruises form. In space, the analogy becomes plasma instead of blood, magnetic loops instead of vessels. And in those loops, the presence of Atlas seemed to cast ripples like shadows across light. Solar physicists measured small shifts in coronal mass ejections and wind speeds around the comet. These could, of course, be explained by geometry, the coma acting as a barrier, diverting flow like a rock in a stream. But the scale of the effect felt exaggerated compared to the nucleus itself. The gas cloud was enormous, and in its enormity it seemed to reach into the corona's domain, sculpting flows that were otherwise smooth. Images from space telescopes reinforced the impression. In ultraviolet light, parts of the corona seemed slightly dimmer when Atlas was nearby, as if energy had been absorbed rather than scattered. No one claimed that the sun's output had diminished, only that, locally, the parasite's halo had pulled light into itself, leaving behind the suggestion of shadow. For scientists, this was a fascinating case study in plasma interactions. For storytellers, it was something more unsettling. The sun's crown, touched by an intruder. The concept of shadow carries weight because the sun is our ultimate source of light. To imagine shadows upon its very aura feels transgressive, a violation of something pure. Even if these were only measurement artifacts, only brief disturbances, the image lingered. The corona, once thought immune to the small, could in fact be shaped by it. Some speculated about resonance effects, magnetic fields from the coma aligning or disrupting loops in the corona, creating flickers like the beating of wings against flame. Others pointed to the carbon dioxide dominance again, noting that the coma might be unusually efficient at capturing ultraviolet photons, draining brightness in wavelengths the corona normally commands. Whatever the mechanism, the impression remained the same. The sun's radiance touched and altered, and so we describe it as shadows across the corona. Not darkness that blocks, but subtle stains, the kind that only instruments and metaphors can see. To the human imagination, it is haunting, a parasite leaving marks on the face of its host. To science, it is a dataset, to be logged and compared, another reminder that even giants respond to gnats. In the end, the sun shines on, untroubled in its vastness. But to know that its corona, that fragile and fiery halo, could bear the marks of a visitor, that knowledge humbles us. For if a body so small can cast shadows across the light of a star, what else might be possible in a universe where imbalance rules? The corona glowed still, but in its shimmering folds, humanity read the signs of feeding. Light from the sun is our most reliable constant. Every morning it returns, every evening it fades, and over billions of years it has remained the foundation of life itself. It is so steady that we measure time, energy, and distance against it. Yet, when 3I divided by Atlas passed through the inner system, some observers began to notice what they described as traces faint, almost imperceptible signs of light being drawn away. This was not the catastrophic dimming of a star, nor anything the human eye could detect from Earth. The sun remained brilliant, unchanged to all who looked up at the sky. But in the careful records of instruments, in the wavelengths dissected by spectrographs, there were tiny anomalies. Photons seemed to vanish in unexpected ratios. Bands of ultraviolet were absorbed more deeply than models predicted. The halo of carbon dioxide around the object became not just reflective, but consuming, taking light in and holding it long enough that its return was muted. It was like looking at a glass of water and noticing, drop by drop, that the level had fallen. Not enough to notice at once, but enough to know that something had been sipped away. For scientists, this raised questions about the optical depth of the coma, about scattering processes, about whether dust grains were larger or smaller than expected. For storytellers, the conclusion was simpler. The parasite was leaving marks, faint scars of drained light in its wake. The idea of drained light is haunting, because light is supposed to be untouchable. You can block it, bend it, scatter it, but you cannot truly drink it. And yet, in the space around 3I divided by Atlas, that is what seemed to happen. The comet's coma was vast enough to intercept huge streams of photons, and instead of merely reflecting them outward, it transformed them. Some were re-emitted as heat, some as faint glow, but much of the original brilliance was lost. The sun's gift had been taken, altered, and carried away. In some measurements, the dust tails themselves appeared dimmer than expected, as though part of the sunlight that should have made them shine had been absorbed instead. These tails became ghostly streaks, less reflective than their geometry suggested. Astronomers debated whether unusual carbon structures in the dust could account for this, absorbing light the way soot does in our own atmosphere. If so, then the parasite's feeding left not just chemical, but visual traces, a faint darkening written into the very material it expelled. Other instruments noticed subtler clues. Polarization shifts in the light passing through the coma, small deviations in the angle of photons, signs that they had been caught and twisted before being released. Each trace was tiny, each one could be explained by physics we already know. But together they painted a picture. The parasite's feeding did not leave the sun unharmed. It left behind a fingerprint in the spectrum, a story written in drained light. For us, here on Earth, these traces were invisible. The daylight never faltered, the warmth of the star never waned. But in the sensitive silence of observatories, they were clear enough to measure, and they told us something profound. Even the brightest source we know is not beyond touch. Even the sun can be altered, if only in whispers. The metaphor sharpens here. Traces of drained light are like bruises on the body of the star, small enough to escape notice, but real enough to reveal impact. The parasite does not devour in one swift motion. It sips subtly, leaving almost nothing behind except these faint marks, detectable only to those who look closely. And so humanity looked closer. Telescopes followed, instruments recorded, and scientists argued. Was this simple chemistry, or was it something stranger? Was it just ice and dust? Or was it a cosmic parasite, leaving faint trails of hunger across the sun's light? The answer remains uncertain. But the traces are there, etched into the record, reminders that even brilliance can be diminished, drop by drop, photon by photon. When astronomers discover a new object in the solar system, one of the first steps is to calculate its orbit. For most bodies, comets, asteroids, planets, these paths are predictable. They are ellipses around the sun, their shapes governed by gravity's quiet precision. The numbers line up, the models agree, and the cosmos feels orderly. But with 3I divided by Atlas, the numbers whispered something different. Its path was hyperbolic, not bound to the sun at all. That alone marked it as interstellar, a traveler from beyond. Yet, even within that category, there were details that unsettled. Its incoming speed was high, higher than many models of interstellar drift would predict. Its angle of approach seemed almost purposeful, slicing inward at a trajectory that took it unusually close to the Sunday. And as it neared, subtle deviations began to appear, motions that seemed to resist the comfort of neat equations. Scientists tried to fit them into familiar causes. Non-gravitational accelerations, perhaps, caused by jets of gas venting from the nucleus. Outgassing can nudge a small body in measurable ways, and comets often wobble as a result. But with 3I divided by Atlas, the accelerations were persistent, directional, as if the object had a steady hand guiding it. In the metaphor of the parasite, this became a chilling image. Not a passive rock drifting, but a feeder adjusting its position, aligning itself with its host. These motions created unease because orbital mechanics are supposed to be reliable. Gravity is the great equalizer, the predictable rhythm by which the heavens dance. When an object does not fit that rhythm, our sense of cosmic security wavers. If Atlas could adjust itself, even subtly, then its relationship with the sun was not just chance, it was interaction. The parasite frame amplifies this unease. Imagine a tick climbing deliberately toward warm skin, guided not by gravity but by hunger. Each small adjustment looks like intention, even if it is only chemistry and physics. In Atlas's case, the jets of carbon dioxide could very well explain the deviations. But to those who watched, the picture was darker, a parasite positioning its straw, drawing nearer to the brightest vein. One striking detail was the steadiness of its brightness. Unlike other tumbling objects, which flash and dim as they spin, Atlas glowed with eerie consistency. Some suggested it was rotating slowly, others that its shape was symmetrical. But in the parasite narrative, that steadiness looked like stability, as if the object had locked itself into a feeding stance, minimizing wasteful wobble, holding its position with quiet intent. Even the sun seemed to acknowledge it, in a way. Solar wind streams bent around the coma, magnetic ripples shifted, as though the star's breath itself was making room for the intruder. Orbital motion and stellar weather became intertwined, a dance that did not quite feel accidental. The discomfort lies not in the danger, for the sun is vast, and Atlas was small, but in the suggestion. If a body from beyond can adjust its path, can appear to hold station, then perhaps others can too. Perhaps feeding on stars is not a fantasy, but a quiet truth of the universe. Perhaps what we saw as an anomaly was, in fact, a glimpse of a broader pattern, one in which stars are not only givers, but also prey. Of course, science remains cautious. The data can be explained without invoking parasites. Outgassing, rotation, uneven surface chemistry all suffice. Yet the metaphor lingers because it resonates. Orbital motions that defy comfort remind us that the cosmos is not always as predictable as we wish. The sun may still shine steadily, but in the subtle deviations of Atlas's path, we saw the shadow of feeding. A parasite moves with purpose, even if hidden beneath natural law, and for a brief moment in 2025, the heavens seemed to hold such purpose, an object drifting, adjusting, and unsettling the quiet order of the sky. The sun's light is relentless. It floods the solar system with energy, warming planets, stirring atmospheres, and igniting the chemistry that makes life possible. When an icy visitor approaches, we expect that brilliance to awaken it. Frozen gases sublimate, dust erupts, and the comet grows brighter. The curve of brightness usually follows a familiar pattern. Steady increase as it nears the sun, a peak at perihelion, and then a graceful decline as it retreats into the dark. But 3I divided by Atlas resisted this rhythm. Its brightness behaved in ways that did not align with expectation. It grew suddenly, surged beyond predictions, and then unsettlingly refused to fade at the rate models suggested. Even after it passed its closest point to the sun, the coma remained active. The glow lingered, as though the parasite had learned to hold on to the energy it had gathered. To astronomers, this was a puzzle of thermal inertia, of particle size, of chemical composition. Perhaps the dust grains were larger, reflecting light more efficiently. Perhaps the dominance of carbon dioxide meant energy was being trapped and re-released over longer timescales. Each possibility was logical, grounded in physics. Yet the persistence of brightness carried another weight, a symbolic one. It looked like feeding. In the parasite metaphor, brightness is the visible sign of consumption. The sun gives, the parasite takes, and the glow of the coma is the receipt of that exchange. Normally, when the host is left behind, the parasite's glow fades, but Atlas clung to its radiance. It seemed unwilling to let go, as if storing the sun's energy, releasing it slowly, savoring the meal instead of moving on. There was something uncanny about the steadiness of that light. Most comets flicker. They tumble, they fragment, their jets sputter. Their glow is uneven, fragile, unpredictable. Atlas, by contrast, radiated with strange consistency. Even as it moved farther from the sun, even as logic dictated it should dim, its coma remained stubbornly bright. To human eyes watching through telescopes, it felt less like a natural decline and more like a sustained appetite. Instruments measuring its spectrum added another layer to the mystery. The energy was not simply reflected sunlight. Some of it was reprocessed, shifted into different wavelengths, scattered and stretched in ways that suggested the coma was doing more than passively shining. It was metabolizing the sun's gift, breaking it down, and radiating it back in altered form. A parasite, not merely glowing, but digesting. This persistence raised unsettling questions. Could such an object, if given enough time, draw enough energy to alter its host in meaningful ways? Could a star's brilliance be drained, not catastrophically, but gradually, by repeated encounters with travelers like this? The sun is vast, and Atlas was tiny, so the answer is likely no. Yet the metaphor forces us to consider scale differently. A single tick does not kill an animal, but a swarm, over time, can weaken even the strongest host. For Earth, there was no danger. The sun remained radiant, our days unchanged, but the narrative carried weight because it touched on our sense of permanence. The sun is not supposed to falter. Its brightness should not fade. And yet here was a visitor that seemed to borrow that light, hold it longer than expected, and remind us that even a star's constancy can be touched. In the silence of observatories, the lingering glow of Atlas was recorded in data points and graphs. In the imagination, it became a lingering mouthful of stolen brilliance, a parasite that, even after moving on, refused to dim, carrying the sun's light within itself like a trophy. The brightness that should not fade became not just an astronomical curiosity, but a metaphorical wound. Proof that even light, our most eternal symbol, can be borrowed, carried, and consumed. Heat is the sun's most constant offering. It radiates outward in every direction, bathing planets, moons, and dust in its glow. For billions of years, Earth has thrived in its warmth, while the outer reaches of the solar system lie frozen under its faint touch. Normally, small bodies like comets receive only what chance delivers: a temporary heating, a brief burst of activity, and then silence once more. But with 3I divided by Atlas, something about this transfer of heat seemed different. Instruments recorded levels of thermal absorption that stretched beyond expectations. The coma did not simply warm and vent, it soaked in energy and held onto it. Dust particles glowed longer, gases remained active farther from the sun than models predicted. To scientists, this suggested unusual chemistry, or perhaps grains structured to trap warmth. But in the parasitic metaphor, it looked like something more deliberate. A siphon of heat, silent and steady, draining the star in ways almost invisible. The siphon is an unsettling image because it suggests direction, the purposeful movement of energy from one body to another. Heat is supposed to scatter, to diffuse endlessly until balance is reached. Yet, around Atlas, the process looked skewed. The coma's composition, rich in carbon dioxide and dark dust, acted almost like insulation. Instead of bleeding energy back into space, it absorbed and stored it, a sponge of warmth floating in the void. This retention made the object seem alive in its hunger. Days, even weeks after its closest pass, Atlas remained more active than a normal comet should have been. Jets continued to erupt. Gases continued to glow. It was as if the parasite had learned to feed slowly, to nurse on the heat long after it should have starved. The silence of this process made it even more haunting. There was no roar, no flash, no sign to the naked eye. Just data points, graphs, and the persistent glow of an object that refused to cool. Astronomers considered whether porous structures in the nucleus could explain it: layers of ice and dust acting as thermal reservoirs, slowly releasing their stores. That explanation made sense, but it did not remove the unease, because in the imagery of a parasite, those porous layers became something else. Channels, capillaries, hidden organs drinking from the sunday. Each pore a straw, each vent a mouth, all working together to siphon heat across distances we barely comprehend. The sun, of course, is not weakened in any measurable way. Its energy output is vast beyond imagining. The heat taken by Atlas is less than a grain of sand from a desert, but scale is not the point. The point is vulnerability. To watch a small traveler capture, hold, and feed on even the tiniest portion of solar heat is to realize that the star's constancy can be touched, that even fire itself can be leached, if only for a moment. Some theorists extended the metaphor further. What if countless such objects drift through the galaxy, each siphoning tiny fractions of stellar heat? What if stars, over eons, are not only powered from within but also nibbled from without? It is speculation, yes, but speculation that unsettles because it places the sun in the role of host, not sovereign. The silence of the siphon is what makes it powerful. No alarm sounded, no changes reached Earth. Life continued under steady skies. Yet, in the margins of observation, the data whispered. Energy had been drawn, heat had been held, and the parasite had fed. In that quiet feeding lies the heart of the story. Not destruction, not catastrophe, but something subtler, a hidden exchange in which the greatest giver of energy was, for once, the one being drained. The sun's surface, the photosphere, is a restless ocean of fire. Currents of plasma rise and fall, sunspots bloom and vanish, and magnetic fields weave patterns of unimaginable complexity. It is not solid, not skin, yet for centuries we have spoken of it as though it were the sun's face. To gaze upon it is to see the star's character, bright, fierce, and seemingly indestructible. And yet, when Three-Eye Divided by Atlas swept close, some observers began to speak of marks, faint disturbances that could be read as wounds. Not wounds in the biological sense, but thermal impressions. Regions where the sun's heat seemed redistributed, where its outflow bent in ways that hinted at contact. These impressions were so subtle they lived mostly in models, in charts of solar wind irregularities and coronal ripples. Still, the metaphor carried weight. A parasite had fed, and the star bore the signs. What would it mean for the sun to carry wounds? In truth, the energy drawn by Atlas was microscopic compared to the star's vastness. But the human mind does not think in absolutes. It thinks in images. The image of a wound conveys vulnerability, a sense that the untouchable can be touched, the eternal can be marked. Even if the damage is negligible, the existence of a mark matters. Some astronomers pointed to temporary cooling in tiny regions of the corona, subtle dips in measured brightness, where Atlas's coma may have absorbed or deflected more radiation than expected. Others highlighted turbulence in the solar wind, knots of plasma that formed downstream of the object, like bruises trailing from a sting. These were not permanent, nor visible to the naked eye. But within the metaphor, they became thermal wounds, small, fleeting, yet undeniable. The parasite image deepens the effect. Imagine a leech leaving behind not only the loss of blood, but also the faint welt of its bite. The host survives, even thrives, but it carries the memory of contact. For the sun, Atlas's passage may have been much the same. A few localized disturbances, a few shifts in thermal balance, nothing catastrophic but enough to remind us that even a star can be scarred. The idea unsettles because the sun is our foundation. It is the measure of constancy, the giver of light we have never seen falter. To imagine it bearing wounds, however faint, is to accept that it is not beyond harm, that in the endless exchange of energy, even a star can be on the losing side. Speculative voices went further. If one such visitor can leave faint impressions, what of many? If countless comets and interstellar bodies pass over millennia, each drawing heat, each casting shadows, then perhaps the sun's surface is not pristine at all, but layered with invisible scars. Wounds that heal quickly, yes, but that speak of repeated contact with the small and the hungry. The science, of course, stays cautious. What Atlas left behind is likely nothing more than disturbances in plasma flow and a momentary redistribution of energy. The star itself continues unchanged, its fire unquenched, its brilliance intact. But the metaphor transforms that science into something more haunting. The sun, mighty as it is, bearing the scratches of a cosmic parasite. And perhaps that is the lesson hidden in these wounds. Not that our star is in danger, but that nothing in the universe is untouchable. Giants can be marked by gnats, oceans by pebbles, stars by comets. In those marks we see the balance of scale, the reminder that even the great can be humbled by the small. For now, the thermal wounds have healed, the sun shines on, and life continues as if nothing happened. But in the memory of observation, in the whispers of speculation, the scars remain faint, fleeting, and forever unsettling. Beneath the vast halo of gas and dust, beneath the glowing coma that spread across hundreds of thousands of kilometers, there lies the true heart of Three-Eye Divided by Atlas, its nucleus. Small, dark, and invisible to the eye, it is the solid fragment around which all else revolves. Scientists estimate it to be no larger than a mountain, perhaps even smaller, a fragment of ice, dust, and ancient chemistry. And yet, in the metaphor of the parasite, this nucleus becomes more than a lump of rock. It becomes the hidden mouth, the place where feeding truly begins. We never saw it directly. Even the most powerful telescopes could not pierce the coma to reveal its surface. All we know of it comes from indirect evidence: the brightness of the halo, the chemistry of escaping gases, the directions of faint jets. But those clues paint an image. Beneath the cloud lies a core riddled with fissures, vents, and cavities. From these fractures, carbon dioxide and dust erupt, forming the straws and siphons through which the parasite drinks from the sundae. In a way, the invisibility of the nucleus makes it more haunting. A predator's mouth is most terrifying when unseen, hidden beneath disguise. We saw only the effects: the streams of gas, the rippling coma, the tail that stretched like a trail of digestion. The source remained cloaked. To the scientific mind, this was simply the limit of observation. To the human imagination, it was the hidden organ of hunger, masked by a shroud of light. Some astronomers noted that the jets of carbon dioxide appeared unusually directed, almost stable, rather than chaotic. This suggested that the nucleus had organized pathways of escape fractures that funneled gas with purpose. In the metaphor, these pathways became teeth or tongues, the mechanics of a feeding mouth. The nucleus was not randomly shedding. It was channeling, focusing, pulling energy into defined routes. Even the rotation, or lack thereof, hinted at this hidden organ. Most comets tumble, their jets producing irregular pushes that spin them unpredictably. But Atlas seemed steady, its brightness consistent, as though its vents were arranged in balance. A hidden mouth, not flailing, but composed, controlling its feeding to remain fixed in place. The darkness of the nucleus also added to the image. If exposed, it would appear blacker than coal, absorbing almost all light. In physical terms, this is normal for cometary material. In symbolic terms, it is chilling. A mouth that swallows light itself, hidden beneath the glowing halo that masks its true appetite. Some speculated whether cavities within the nucleus stored heat, releasing it slowly to fuel continued outgassing. If so, the mouth was not only active at perihelion, but remained open long after, feeding in silence, like a creature chewing even after the first bite, savoring the meal before letting go. To imagine the nucleus as a hidden mouth is to give shape to our unease. It makes sense of the object's persistence, its brightness, its strange chemistry. A mouth consumes, a mouth holds, a mouth drains. And though we know Atlas is only ice and dust, the metaphor gives it purpose, a role in the cosmic drama of host and parasite. The sun, vast and radiant, still shines without interruption, but in the story told through observation, it was touched by an unseen mouth, small, dark, and hungry. A mouth that left no scars we could see, but left impressions in the way light shifted, heat lingered, and plasma rippled. In truth, the nucleus remains hidden, its secrets carried back into interstellar night. We may never know its exact size, its shape, or its scars. But we know this. It was the organ of the parasite, the mouth behind the mask, the silent center of a feeding that shook our imagination. For as long as humanity has looked to the skies, the sun has been the one constant. Civilizations have risen and fallen under its gaze, measuring their days and seasons by its light. It is the archetype of strength, eternal, unwavering, immune to change on any human scale. But with the passage of 3, divided by Atlas, some began to ask an unsettling question. Could even the sun show signs of weakness? No telescope on Earth captured the sun dimming, of course. No human eye saw a change in its brilliance. Yet, in the meticulous records of observatories, in the sensitive graphs of spectrographs and plasma detectors, there were anomalies. Tiny dips in brightness at certain wavelengths. Fluctuations in the solar wind that seemed more chaotic than usual. Irregularities in the corona's structure, as if the star's outer skin had been brushed by an intruder. Individually, these anomalies could be dismissed. Dust in the coma absorbing light. jets of gas interfering with plasma flows, random noise in instruments. But together, they began to look like a pattern, a faint but suggestive picture. The sun, normally a steady giver, had been touched, nudged, and altered if only slightly by a passing parasite. In the metaphor, these were not anomalies but symptoms, signs of weakness, however fleeting. The parasite had taken its sip, and the host bore the faint marks of being drained. One of the most striking observations was the persistence of activity in Atlas even as it moved away. Normally, a comet fades quickly once it leaves the sun's embrace. Yet Atlas remained luminous, still glowing with captured energy. This persistence implied that it had stored more heat, more light than expected. And if it carried that energy with it, then the sun had lost it. To us, the loss is negligible. To the metaphor, it is weakness, the star giving something away it cannot reclaim. Other clues came from the solar wind. Instruments detected disturbances, small ripples that stretched far downstream of the object. Plasma bent, fields shifted, turbulence increased. Again, nothing catastrophic, but enough to suggest that the star's breath had been caught and altered. To imagine the sun's exhalation interrupted, its steady outflow disturbed, is to imagine the great star momentarily unsteady in its strength. Signs of weakness also live in symbolism. The sun is not supposed to be vulnerable. It is the image of permanence, the source of life. And yet, by framing it as a host to a parasite, we reveal how fragile even giants can feel. Just as an animal can carry ticks without ever faltering, the sun may endure countless encounters without harm. But the presence of the parasite still changes the story. The invincible becomes touchable. The eternal becomes susceptible. Speculative thinkers took this further. What if interstellar parasites are not rare but common? What if, across eons, stars slowly leak energy into the comas of countless visitors? Individually, the loss is trivial, but collectively it might add up. Stars that should shine steadily could dim fractionally sooner. The weakness may never reach human eyes, but it could be written in the deep histories of galaxies. The science holds us back, reminding us that the sun's lifespan is secure, its fusion furnace unshaken. But imagination pushes forward, insisting that weakness is relative. The strongest creature can still bleed. The brightest star can still cast shadows of vulnerability. So, we are left with this quiet contradiction. The sun still burns with its full brilliance, its strength unchanged. Yet, in the record of 3 I divided by Atlas, in the disturbances and anomalies, we glimpse the possibility that even the mighty can be touched. And in those faint touches, we see not destruction, but the suggestion of weakness enough to remind us that no host, however vast, is beyond the reach of parasites. Every comet announces itself with a tail. As it nears the sun, heat strips away ices, solar wind sweeps up dust, and the two form luminous streams that stretch across the void. These tails are beautiful, ethereal banners of light and shadow, visible reminders that even the smallest body can weave with sunlight. They are always pointed away from the sun, carried by radiation pressure and plasma flow, as if the star itself is pushing the material outward. With 3 I divided by Atlas, the tail took on a more haunting symbolism. To the scientific eye, it was a standard feature, composed of dust and carbon dioxide, streaming as expected. To the imagination, however, it became something else. The evidence of feeding. The trail of a parasite carrying pieces of the sun away with it. Observers noted how the tail seemed broader and denser than models suggested. Its brightness lingered, its structure persistent, as though more energy and matter were being transferred than usual. In simple terms, this could be explained by chemistry, carbon dioxide venting earlier and stronger than water, lifting dust in greater quantities. But in metaphorical terms, it looked like a siphon at work. The sun's light entering the coma, transformed into dust and gas, and then expelled into space. Each grain in the tail became a particle of stolen brilliance, a fragment of solar energy carried away. The direction of the tail added to this impression. Always pointing away from the sun, it traced a line that looked like a wound, a scar stretching outward, showing the path of what had been taken. For those who imagined the sun as a host, the tail was the evidence of blood loss, the thin stream leaving the body, trailing behind the parasite as it fed and moved on. Some astronomers remarked on faint structures within the tail, striations, knots, variations in brightness. These could have been the result of magnetic fields interacting with dust or uneven bursts of gas from the nucleus. Yet within the narrative of feeding, they appeared like veins, channels through which the star's essence flowed, organized and structured, not random at all. What made the image so powerful was not danger, but symbolism. The sun, vast and untouchable, seemed to be leaking, not collapsing, not dimming, but leaving small traces of itself in the wake of a traveler from beyond. It is unsettling to think that a star can be reduced, even in the smallest measure, by something so small. The tail became the visible proof that energy can be borrowed, that light can be carried away. Of course, the sun will not notice the loss. Its furnace continues, its brilliance unbroken. The matter in Atlas's tail is insignificant compared to the oceans of plasma within the star. But the lesson lies in perspective. A parasite does not need to destroy its host to leave a mark. It only needs to take enough to survive, enough to prove that the giant can be touched. The tail of Atlas stretched behind it like a thread of hunger, weaving across space, fading slowly into darkness. Somewhere within that trail were atoms that once belonged to the sun, photons captured and transformed, now carried away into interstellar night, a fragment of our star, leaving forever, tied to the path of a parasite. And so the tail became more than a plume of dust. It became a story of feeding, of transfer, of a star giving something it could never reclaim. The sun still shines, but a piece of it now drifts outward, bound to the journey of 3I divided by Atlas, as if the parasite had taken not only energy, but memory, carrying the star's light into the endless dark. Around every active comet forms a cloud, a vast, shimmering coma of dust and gas, born from the simple act of sunlight striking frozen surfaces. To most astronomers, this is the familiar signature of sublimation: ice transforming into vapor, dust carried outward by invisible winds. It is chemistry and physics, not mystery. But when 3I divided by Atlas passed close to the sun, the scale of its cloud startled even seasoned observers. It was immense, sprawling far beyond predictions, a haze so large that the nucleus itself disappeared completely from view. Within the metaphor of the parasite, this cloud became something darker. Not just a veil of activity, but a floating aura of consumed matter, a shroud formed from the sun's own energy, processed and expelled, lingering like the breath of a creature that has just fed. Telescopes revealed that the coma was not only broad but dense. Its particles reflected and absorbed light in unusual ways, scattering photons into halos that stretched across the field of vision. Carbon dioxide dominated the spectrum, carrying with it fine dust grains that glowed faintly in infrared. To science, this was a clue about the object's origins and chemistry. To the imagination, it was evidence of a meal digested in plain sight. The sun's gift transformed into a cloud that clung to the parasite like vapor rising from a feast. The persistence of the coma made it stranger still. Normally, such clouds thin quickly once an object passes perihelion, the point of closest approach. The sun's heat fades, and the comet's activity quiets. Yet Atlas's halo remained vigorous longer than expected, as if it had stored excess energy and continued to vent it slowly. The cloud did not look like a fleeting burst, but like the smoke of a sustained fire, a steady exhalation of consumed matter. Some astronomers describe structures within the coma, filaments, arcs, and asymmetries that suggested organized jets beneath the surface. These patterns hinted at direction, as though the cloud were not random but sculpted. In the metaphor, they became the marks of digestion, the way a parasite processes its food, channeling it outward into deliberate forms. The coma was no longer just a passive mist, it was the visible result of feeding. There is something unsettling about a cloud, that vast surrounding something so small. The nucleus itself might be only a few kilometers across, but its halo stretched hundreds of thousands of kilometers in every direction. To imagine such disparity is to confront imbalance, a tiny mouth creating a vast aura of consumption, a parasite whose meal leaves a stain far larger than itself. The symbolism deepens when we consider what the cloud contained. Each grain of dust carried the energy of the sun within it, heated, lifted, and expelled into space. Each molecule of gas was once frozen in silence, now animated by the warmth of a star. Together, they formed a drifting archive of solar energy, scattered and dispersed, never to return. In essence, the cloud was a memory, the trace of what had been taken, floating as evidence around the feeder. Of course, in scientific terms, the sun remains untouched. The amount of energy and matter lost is negligible, but the metaphor transforms scale into meaning. If even a star can leave behind a cloud of consumed matter, however small, then perhaps nothing is beyond being fed upon. Perhaps the cosmos is full of these subtle exchanges, hosts and parasites locked in quiet cycles of giving and taking. And so the cloud of Atlas draped across the sky, invisible to most, yet vast beyond imagining. To the human eye, it was only a faint glow in the telescope. To the human mind, it was something more. A cloud that testified to feeding, a vaporous shadow of consumption, drifting onward with the parasite into the dark. The sun is not a solid sphere, but a layered furnace. Deep at its core, nuclear fusion rages, fusing hydrogen into helium and releasing the energy that sustains our world. That energy migrates outward, first through the dense radiative zone, then the more chaotic convective zone, and finally to the visible surface we call the photosphere. Beyond that lies the corona, a tenuous halo of plasma stretching far into space. To us, these layers are eternal, robust, unyielding. But when 3I divided by Atlas swept close, a new metaphor arose, one that imagined the sun not as a titan of endless strength, but as a host whose layers could be touched, disturbed, even thinned. The comet's vast coma and unusual chemistry seemed to pull at the star in subtle ways, altering the balance of light and heat. Individually, the effects were imperceptible, yet in the language of narrative, they became signs of something more. The layers of the sun growing thin. Scientists recorded small anomalies, slight dips in ultraviolet brightness, irregularities in coronal loops, disturbances in the solar wind traced back to the space around Atlas. None of these could be called damage, but to the imagination, they were scratches upon the sun's skin, hints that even the outermost layers of our star could be affected by a visitor so small. The metaphor intensifies when we think of the sun as an onion of fire, each layer guarding the next. If the outermost strata can be touched, if photons can be caught, if plasma can be siphoned, if light can be absorbed into a passing halo, then those protective shells no longer feel impenetrable. They feel fragile, as if thinned by contact, like cloth rubbed threadbare by friction. What makes this unsettling is not the scale of the effect, which is tiny, but the reversal of roles. The sun is supposed to be the giver, the feeder, the inexhaustible parent of the solar system. But in the presence of 3I divided by Atlas, it looked briefly like the one being fed upon. Its layers became not barriers but offerings, peeled back ever so slightly by the siphon of a parasite. Astronomers tried to stay grounded. They spoke of sublimation fronts, of jets of carbon dioxide altering local plasma conditions, of scattering processes that could explain the anomalies. They reminded us that the sun loses mass constantly through its solar wind, and that one small comet could never threaten its equilibrium. Yet the metaphor lingered, because it spoke to something deeper, our fear that nothing, not even the brightest star, is immune to loss. In some measurements, the density of plasma just beyond the corona appeared to fluctuate more than expected. These could have been caused by ordinary solar turbulence. But framed differently, they looked like gaps, thinned patches where the sun's aura had been disturbed. Shadows across the corona became thinning in its layers, the kind of subtle depletion that, if repeated often enough, might wear a star down. Speculative voices asked unsettling questions. What if countless interstellar objects pass this way, each taking a fraction, each peeling off a sliver of energy, each leaving the sun just a little thinner, not enough to notice in years or centuries, but enough to matter in the fullness of cosmic time? Could stars age not only from within, through fusion, but also from without, through the countless small drainings of parasites? Of course, the science does not demand this conclusion. The sun remains healthy, vigorous, unweakened by Atlas, yet the metaphor insists. The encounter showed us that even giants can be touched, even layers of fire can be thinned, if only symbolically. And so, in the memory of 3 I divided by Atlas, we imagine the sun differently, not as invincible, but as layered, vulnerable, and perhaps even consumable. Its brilliance still floods our skies, but somewhere deep in our collective imagination, the layers feel less solid, less eternal. They feel thinner, as though the parasite had peeled them back, leaving us to wonder how long even the brightest of lights can endure. One object passing through the solar system is an event, 2 objects a coincidence, but 3, 4, a dozen that begins to look like a pattern. When 3 I divided by Atlas appeared, it was the 3rd interstellar visitor ever recorded by humanity. Oumuamua had come first, a long, tumbling fragment. Borisov followed, a more traditional comet. Then Atlas arrived, stranger than either, brighter, with a chemistry that defied our models. Each time, astronomers spoke of rarity, and yet the timeline suggests something else. Perhaps interstellar travelers are not rare at all, but common. Perhaps we have only just begun to notice. It is here that the idea of the parasitic swarm theory takes shape. If 3 I divided by Atlas is a parasite, feeding on the sun in subtle ways, then what if it is not alone? What if countless such objects drift between stars, not randomly, but as part of swarms coordinated or coincidental, but always feeding? The swarm theory unsettles because it transforms a single story of hunger into a collective one. A lone parasite is a curiosity, a swarm is a threat. We know this instinctively from nature. A single mosquito is an annoyance, but a swarm can overwhelm. Locusts can strip entire fields bare, not because of their individual power, but because of their numbers. Could the same logic apply in space? Imagine, for a moment, dozens of Atlas-like objects sweeping past a star, each with its vast coma, each drawing in photons, each siphoning heat, each carrying away fragments of energy locked in dust and gas. The effect on the star might still be minuscule in human terms, but over cosmic timescales, and across billions of such encounters, the cumulative drain could matter. Stars could be subtly weakened, their lifespans shortened not only by their internal burning but also by external parasites, drifting and feeding like interstellar locusts. Some speculative thinkers even suggested coordination. What if the swarms were not random debris, but fragments of something larger, a shattered body sent deliberately, or the remnants of engineered probes. The idea edges into science fiction, but it lingers because the motions of Atlas sometimes felt too neat, its chemistry too strange. If one parasite can feed, perhaps many can be deployed. The swarm theory also reframes our own vulnerability. The sun is immense, and one visitor cannot harm it. But what of Earth? A dense enough swarm could scatter dust across our orbit, dimming sunlight, altering climate, reshaping the conditions of life. The feeding would not be of the star alone, but of its children. Humanity might never know whether it was natural or intentional, only that the sky grew dim. Of course, the science urges caution. There is no evidence of swarms. What we call rare may simply feel rare because we have not been watching long enough. Interstellar visitors may be as common as raindrops, scattered across time and space without pattern. And yet, the metaphor carries weight precisely because it mirrors truths we already know. Parasites rarely act alone. They thrive in numbers. They swarm. In this light, Atlas is no longer just a solitary feeder, but a messenger of possibility. It shows us what is possible on the small scale, a coma that acts like a siphon, a tail that carries the sun's energy away, a nucleus that feeds like a hidden mouth. If one object can do this, why not many? If one parasite can touch the star, why not a swarm? The theory is speculation, yes, but it asks us to see the cosmos differently, not as a stage of solitary wanderers, but as a theater of swarms, where stars are not only beacons but also feeding grounds. And if that is true, then the sun, our eternal constant, is not invincible at all. It is only the latest host in a galaxy where parasites drift quietly, waiting for their turn to feed. In nature, parasites rarely exist in isolation. A single tick may cling to the skin, a single leech may draw blood, but the real danger comes when they multiply. Replication ensures survival, ensures spread, ensures that the host is never free of their presence. It is this thought that makes the idea of 3I divided by Atlas even more unsettling. For if one parasite can feed on the sun, what would happen if it could replicate? Replication is not something we normally associate with comets or interstellar objects. They are inert fragments of ice and dust, drifting without life, without intent. Yet 3I divided by Atlas challenged our assumptions. Its coma was unusually vast, its chemistry unusual, its brightness persistent. It did not behave exactly like a normal comet, and in that gap between expectation and reality, imagination entered. What if Atlas could split, reproduce, or seed copies of itself? Astronomers already know that fragmentation is common. Many comets split under the stress of sunlight and gravity. Their fragile bodies crack, vent, and scatter into smaller pieces. Usually, these fragments fade quickly, dissolving into dust. But with Atlas, some speculated that the process could be different. What if its fragments were not weaker, but equally active? What if each shard carried the same chemistry, the same siphoning halo, the same ability to feed? In that scenario, replication is not reproduction in the biological sense, but in the mechanical one. One body becoming many. A single parasite splitting into a swarm. Each fragment forming its own coma, each one siphoning photons, each one drawing tiny portions of the sun's heat. The host would not be faced with one feeder, but with many. The metaphor darkens further when we consider intentionality. If Atlas were natural, fragmentation might be random, chaotic, and short-lived. But if it were something more, if it carried design, however ancient, then replication could be strategy. A way to ensure survival by multiplying. A way to extend feeding by spreading. The parasite would not just survive the encounter, it would amplify it. Imagine the sun surrounded not by one coma, but by dozens. Tails crisscrossing, shadows stretching across the corona, clouds of consumed matter drifting outward. The amount of energy taken would still be negligible in cosmic terms, but symbolically, it would transform the encounter. The sun would no longer face a visitor. It would face an infestation. Even Earth might feel the consequences. Multiple fragments could scatter dust across our skies, dimming starlight, reddening sunsets, altering the transmission of sunlight. Climate shifts, though temporary, could occur. Humanity would not see the parasite directly, but it would feel the touch of its replication in the air, in the seasons, in the harvests. The science reminds us that none of this has been observed. Atlas did not leave behind a chain of replicas in our data. Its fragments, if any, were too faint or too brief to matter. But the metaphor compels us to imagine, what if replication is not an accident, but a pattern? What if interstellar parasites ensure their survival not by endurance alone, but by multiplication? In that light, replication becomes the true danger. A lone feeder is survivable. A multiplying one is not. Stars could face waves of parasitic clouds, each one born from the splitting of another, each one carrying the ability to drain. The galaxy, then, becomes not just a sea of wanderers, but a breeding ground of feeders, endlessly replicating, endlessly hungry. For now, the sun remains strong, its layers intact, its brilliance unbroken. But the thought lingers. If the parasite replicates, then no star is truly safe. What was once a fleeting encounter could become an enduring presence, and what was once a single mouth could become many a swarm born from replication, feeding not for moments, but for ages. Every comet leaves a trail. Dust and gas, torn from its body, are carried into space, forming streams that can stretch for millions of kilometers. When Earth passes through such a trail, we see meteors' brief flashes as fragments burn in the atmosphere. These trails are normally harmless, remnants of a comet's slow erosion under sunlight. But with 3I divided by Atlas, the trails told a different story. They were not only remnants of ice and dust, they were rich in carbon, especially carbon dioxide, in ratios unusual for comets from our own solar system. This abundance gave the impression that the parasite was leaving something behind, not random debris, but scars, trails that spoke of feeding, evidence of what had been taken from the sun and carried away. The metaphor is powerful because scars imply damage. They are not simply marks of passage but records of injury, proof that an encounter has left its mark. In the wake of Atlas, the carbon trails became those scars, strands of dark material, faint and diffuse, like bruises stretching through the void. They did not wound the sun in any literal sense, but symbolically, they looked like the scratches left by a hungry guest. Carbon itself deepens the symbolism. On Earth, we know it as the basis of life, the building block of biology. In space, carbon is the marker of chemistry, the fingerprint of ancient processes. When Atlas exhaled carbon dioxide into its tail and coma, it did more than vent gas. It marked the sun with its feeding. Each molecule was a receipt, a record of energy taken in, processed, and expelled. Some astronomers noted the density of these trails. They seemed thicker than expected, lingering longer, absorbing more light. Dust grains coated in carbon can act like tiny shadows, darkening the paths they leave. Through telescopes, these paths appeared as faint streaks of absorption, strips of dimness against the brilliance of the solar wind. In the metaphor, these became scars across the sun's face, not deep, not fatal, but visible enough to remind us that feeding had occurred. What unsettled observers most was the persistence. Even as Atlas drifted outward, its carbon trails remained behind, orbiting the sun long after the object itself was gone. This meant that the parasite's scars were not fleeting. They became part of the star's environment, evidence of contact lingering in the solar system itself. Earth may one day pass through those trails, encountering the dust of a feeding event that began years earlier. In that moment, the scars would touch us too, falling as faint meteors, tiny fragments of an ancient parasitic meal. The science offers simple explanations. The trails are the natural result of volatile chemistry, of CO2 venting from beneath a crust, of dust carried outward by gas. There is no intent, no design, but the metaphor transforms them. The trails are no longer random. They are scars, deliberate or not, inscribed into space as testimony. And what is a scar if not memory? The sun, in its vastness, may not feel the loss, but the cosmos remembers. Carbon trails mark the feeding as surely as claw marks across skin. They endure, faint but real, long after the parasite has drifted back into darkness. So we are left with the image of a star touched, altered, and scarred. Not weakened in any catastrophic sense, but not untouched either. For even light can leave shadows, and even stars can carry marks. The carbon trails of 3I divided by Atlas are those marks feeding scars that remind us that in a universe of endless exchange, even giants can be wounded, and even wounds can linger. In the cosmos, hunger does not always look like jaws or teeth. Sometimes it takes the form of patterns, arcs, spirals, lines of force, and the subtle mathematics by which energy is drawn from one body to another. With 3I divided by Atlas, observers noticed that its feeding did not unfold as chaos. The coma, the tail, the jets of gas, they all hinted at structure. There was a geometry to the way the parasite consumed. Telescopes revealed jets erupting from the nucleus in regular directions, not scattered randomly, but shaped into arcs that repeated over time. These jets carved filaments into the coma, filaments that bent under solar radiation pressure into sweeping curves. At first, astronomers explained this as rotation, the spin of the nucleus exposing vents in cycles. But the impression lingered that something more deliberate was at play. The parasite's hunger was not frantic. It was organized, expressed in geometry. The tail, too, carried this sense of design. Instead of a uniform blur, its carbon-rich dust formed striations, bands of brightness and dimness that stretched like lines across the sky. These lines, seen in long-exposure images, looked almost like veins, channels carrying energy away from the star. To science, they were interactions of dust size, plasma flow, and magnetic field. To the imagination, they were arteries of hunger, geometric scars etched into space itself. Even the halo of the coma seemed to participate. It was not perfectly round, as many comae are. Instead, it bulged, thick in some regions and thin in others, as if responding to invisible streams of nourishment. The geometry resembled a net cast into the flow of solar particles, adjusting itself to maximize capture. In the metaphor, this became the mouth opening wider, angling itself for the richest flow. Why should hunger take a geometric form? Because nature itself is geometric. Rivers carve fractals into deltas. Plants grow in spirals, shells in logarithms. Feeding often follows pattern, not randomness. A parasite on Earth attaches at points of weakness, repeating its geometry across its host. Atlas seemed to mirror this principle in space, creating not random scars but ordered ones, as if hunger itself had a shape. Some theorists speculated whether the geometry could even be a signature. If objects like Atlas are natural, their jets and trails should vary widely. But if they are part of a broader phenomenon, if parasites drift from star to star, then perhaps their feeding leaves recognizable patterns, a geometry that, once understood, could be distinguished from random comets. In that sense, Atlas's hunger might not only be an act, but also a message, written in shapes of dust and gas. The symbolism unsettles because it blurs the line between the natural and the intentional. Geometry feels deliberate. It suggests order, purpose, perhaps even design. To see geometry in hunger is to imagine a parasite that is not only feeding, but feeding intelligently, arranging itself, aligning itself, maximizing its draw. Whether true or not, the impression stirs unease. The sun, vast and chaotic, seemed momentarily caught in a net of order spun by something far smaller. Of course, the science is simpler. Jets vent where fractures allow, dust arranges itself according to physics, and magnetic fields sculpt plasma into arcs. But the metaphor transforms this simplicity into something deeper. The geometry is no longer just a consequence of physics. It is hunger, structured and precise. And so we are left with the image of a star not simply shining into emptiness, but shining into patterns of consumption. Its light, its heat, its particles captured not randomly, but geometrically, drawn into veins and nets that speak of appetite with structure. Hunger has form, and Atlas showed it to us. A geometry etched in dust and gas, a design of feeding carried on the smallest scales, written across the brilliance of a star. The heliosphere is the sun's invisible shield, a vast bubble of charged particles blown outward by the solar wind. It extends far beyond the planets, reaching to the edge where interstellar space begins. Within it, every planet, moon, and fragment of dust lives under the influence of the sun's breath. Normally, this bubble hums with steady rhythm, streams of plasma flowing outward, magnetic fields spiraling like unseen threads, shock waves rising only from the occasional storm or flare. But when 3I divided by Atlas passed through, astronomers noticed subtle ripples, faint disturbances that did not quite belong. They were not storms, not eruptions, not ordinary turbulence. They were small irregularities that spread outward like whispers. In the metaphor of the parasite, they were echoes in the heliosphere, the faint aftershocks of feeding. The idea of an echo is haunting because it suggests that an event lingers long after the act itself. A voice fades, but its reflection remains. A drumbeat ends, but its resonance travels. In the same way, Atlas seemed to leave traces in the solar wind, echoes of its brief encounter with the star. Measurements showed minor shifts in particle density, tiny fluctuations in plasma velocity, and unusual deviations in magnetic fields near the object. These could all be explained by the comet's vast size, acting like an obstacle in the solar wind. And yet, the scale of the disruption seemed disproportionate. A nucleus no larger than a mountain should not ripple through a bubble billions of kilometers wide, and yet it did. To the scientific mind, this was an opportunity to refine models of solar wind interactions. To the metaphor, it was something more visceral. The parasite had fed, and the host's breath carried the memory of it. The heliosphere itself became the canvas of the wound, painted with echoes that spread outward, faint but undeniable. These echoes are important because they remind us of connection. The sun is not isolated. Its influence stretches across the solar system. Any disturbance, however small, can ripple outward, touching planets, moons, even the edge where the interstellar medium presses back. If a parasite feeds, even gently, the effects are not confined to the star. They echo across the bubble, felt in places far removed from the original act. Some theorists speculated about resonance. Could repeated feeding events, spread across time, layer their echoes upon one another, creating larger patterns? Could the heliosphere itself carry scars of countless encounters, faint disturbances that, if mapped, might reveal the history of parasitic visitors? The idea is speculative, but evocative. The bubble around our star has a memory field, filled with the echoes of every object that has ever touched it. The symbolism grows darker when we imagine these echoes not just as ripples, but as symptoms. A cough in the breath of a star, a shiver in its wind, a reminder that even giants can be unsettled. The sun remains strong, of course, its fusion unbroken, its brilliance unchanged. But the echoes suggest vulnerability, the kind of subtle marks a parasite always leaves behind. For Earth, these echoes were too faint to matter. Our skies did not dim, our climate did not shift, but the instruments heard them, and the data preserved them, small deviations written into the endless flow of plasma. To those who looked closely, they were a reminder that nothing in the heliosphere is untouched. Everything responds, even if only with whispers, and so we are left with the image of a star that carries its encounter outward, into the very bubble that protects its children. The parasite fed, and the echoes spread, filling the heliosphere with faint reminders of loss. Not enough to harm, but enough to unsettle. Enough to teach us that even the breath of the sun can tremble when touched. The sun does not only shine with light, it breathes. From its surface streams a constant flow of plasma, charged particles hurled outward at supersonic speeds. This solar wind fills the heliosphere, carrying with it the star's magnetic fields, invisible yet powerful. Normally, comets are too small to do more than ripple this flow. Their comet act like stones in a river, creating turbulence that quickly fades downstream. But with 3i divided by Atlas, the ripples became something larger, stranger, and more unsettling. Close to the feeder, as some began to call it, the plasma did not behave as expected. Instruments measuring solar wind density and velocity near the object recorded disturbances that were disproportionate to its size. The coma seemed to act not just as an obstacle, but as a siphon capturing charged particles, slowing them, redirecting them. Around Atlas, the solar wind faltered, as if the parasite had found a way to drink from the sun's very breath. These disturbances manifested in subtle ways. Bow shocks formed farther out than models predicted, rippling arcs of plasma that bent around the coma. Magnetic fields, normally smooth spirals, became tangled, showing signs of compression and twist. Downstream, scientists detected wakes that stretched longer than anticipated, trails of altered plasma that continued far beyond the comet's path. To the scientific eye, these were fascinating anomalies, worthy of new models and simulations. To the metaphor, they were feeding scars in the star's wind disturbances carved by the mouth of a parasite. The feeder did not simply consume photons and heat. It touched the sun's plasma, diverting the star's lifeblood in invisible currents. One unsettling aspect was the silence of it all. There were no bursts, no eruptions, no catastrophic shocks. The plasma bent quietly, obediently, around the intruder. It yielded without resistance, flowing into patterns shaped by the coma's magnetic interactions. In this silence, the metaphor deepened. The parasite fed unnoticed, leaving behind only disturbances subtle enough to escape all but the most sensitive instruments. Some observers compared the effect to the behavior of magnetospheres around planets. Earth, for example, carves a cavity in the solar wind, a protective bubble shaped by its magnetic field. Atlas seemed to create something similar, but on a scale far larger than its nucleus could justify. It was as if the parasite had extended a cloak, a feeding field, that bent plasma far beyond its physical reach. Speculative thinkers pushed further. Could such plasma disturbances be intentional? Could the parasite be using them to stabilize its position, to hold itself steady while feeding? The idea remains science fiction, but the imagery lingers. A feeder not only sipping but manipulating the star's breath to remain attached. The metaphor becomes most haunting when we imagine these disturbances as veins. The solar wind, normally rushing outward freely, became momentarily channeled into new paths, curved by the feeder's presence. Each curve looked like a line of hunger, an artery bent toward a mouth. The sun still exhaled, but part of its exhalation no longer belonged to it. In truth, the sun remains vast, unchanged, its wind still carrying billions of tons of plasma outward every second. Atlas's disturbances are minor, lost in the greater storm. Yet, for a moment, the symmetry was broken. The star's breath trembled near the feeder. And that is what unsettles us. Not that the sun was harmed, but that it was touched. Its plasma, its endless wind, was bent and drained, however slightly, by something so small. The disturbances remind us that even giants yield when approached in the right way. So we are left with the image of a parasite feeding quietly in the stream of solar breath. No violence, no resistance, only disturbances, faint but real, written into the plasma near the feeder. Echoes of hunger in the wind of a star. In the story we have been telling, 3I divided by Atlas appears as a parasite, a small but hungry traveler that feeds on the sun's energy. The image is one of imbalance, the great star giving, the small intruder taking. Yet in nature, hosts are not always defenseless. Some resist, some retaliate, some adapt. And so the question arises, can the sun fight back? On the surface, the answer seems obvious. The sun is unimaginably powerful. Every second, it emits more energy than billions of Earths could consume in their lifetimes. Its magnetic storms can strip atmospheres from planets. Its flares can cripple satellites across vast distances. Compared to that, Atlas is nothing a grain of dust caught in a hurricane. If the sun wished, it could incinerate a body like Atlas without effort, and in a way, it already does. The intense radiation near perihelion is brutal. Temperatures soar, particles bombard, plasma storms rage. Many comets do not survive these encounters. They fragment, shatter, dissolve into clouds of dust that fade into nothingness. This is the sun's natural defense, sheer overwhelming energy. For Atlas, every molecule vented, every grain torn free, was evidence of the star burning it alive, even as it fed. Yet, paradoxically, this destruction is also what enables the parasite's feeding. The same radiation that can break a comet apart also fuels its coma, its tail, its glow. The sun, in lashing out, provides the very sustenance the parasite consumes. It is as though the host's attack becomes the feeder's meal, energy repurposed into hunger. The sun cannot help but nourish, even in its violence. Still, the sun has other weapons. Coronal mass ejections, massive eruptions of plasma can fling billions of tons of material into space. If one of these struck Atlas directly, the impact could scatter its coma, disrupt its feeding, even push it off course. Some theorists wondered if the slight irregularities in the object's trajectory were not just caused by its own jets, but by solar storms nudging it with invisible fists. If so, then the sun did fight back, if only instinctively, the way a body twitches against an irritant. But what does it mean for a star to resist? The sun does not choose, does not aim, does not decide. Its responses are automatic, born of physics. And yet, the metaphor makes them feel like retaliation. A host, bleeding light, yes, but also burning, flaring, lashing, unwilling to be consumed without protest. The unsettling truth, however, is that the sun does not need to fight back. It is too vast to be harmed in any meaningful way. Atlas may sip at its light, disturb its plasma, carry away a trace of its brilliance. But these losses are trivial compared to the star's abundance. The parasite cannot wound the host in any lasting sense. It can only remind us that even giants can be touched. Still, the question lingers, because it is human to imagine conflict. We picture balance, predator and prey, host and parasite locked in struggle. And in the case of Atlas, the imagery supports it. The star flaring, the comet feeding, the two entwined in a quiet battle of scale. The sun, vast and eternal, shines as both victim and victor, both feeder and defender. So can the sun fight back? In one sense, yes. Its radiation scalds, its plasma batters, its storms scatter. Atlas feeds only because the sun allows it, and in the end, the star will always endure. In another sense, no. Its very act of aggression becomes nourishment, its endless brilliance the food that sustains the parasite. The sun cannot stop giving, and so it cannot stop being consumed. In that contradiction lies the haunting truth. The host is powerful beyond measure, yet powerless to deny what clings to it. The sun fights, but its fight is also its gift. And the parasite, small and fragile, survives only because the star cannot help but shine. The solar wind is the sun's breath, a constant outflow of charged particles, racing through space at hundreds of kilometers per second. Invisible to the eye, yet powerful enough to sculpt planetary atmospheres. It is the quiet current that fills the heliosphere and defines the space we live in. Usually, this wind flows steadily, like an endless river of plasma. But when 3I, divided by Atlas, entered the inner solar system, observers noticed ripples, disturbances, and signals that seemed out of place. To some, they became the first true signs in the solar wind that the parasite was feeding. Spacecraft tuned to monitor plasma streams recorded shifts in density as the comet passed. Regions of unusually compressed particles trailed behind it, wakes that extended farther than its physical body could explain. Magnetic fields, normally smooth and spiral-shaped, bent in new directions, as though the flow had been redirected around an obstacle larger than the comet itself. In one sense, this was natural. The coma of gas and dust is vast, and the solar wind must curve around it. But the degree of distortion seemed exaggerated, as if the halo was not just blocking the wind, but shaping it, pulling it in, and altering its course. To the scientific mind, this became a question of interaction. Was the carbon dioxide coma more effective at coupling with the solar wind? Were dust grains charged in such a way that they influenced plasma more than usual? These were plausible explanations. Yet in the metaphor of the parasite, the imagery was more chilling. The comet's halo acting like a siphon, drawing not just photons and heat, but the very breath of the Sunday. What unsettled observers further was the persistence of these signatures. Long after Atlas had passed its closest point, the wake in the solar wind remained visible, a trail of altered plasma stretching outward. It was as though the feeding had left scars not just in light, but in the star's own exhalation. Like smoke rising long after the flame, the signs lingered, evidence of consumption written into the currents of space. Some scientists compared it to Earth's magnetosphere, which creates a bow shock in the solar wind as particles are deflected. Atlas's coma seemed to act the same way, but on a scale disproportionate to its nucleus. The parasite, in this framing, extended a feeding field, intercepting the solar wind over distances too vast for its size. The sun's breath was bent, rerouted, absorbed. The symbolism runs deep. Breath is life, and to see the sun's breath disturbed is to imagine its vitality being touched. The parasite, small and fragile, seemed to alter the wind of a star, leaving it momentarily ragged. Not enough to harm, but enough to show that even the most constant outflow can be bent by hunger. Speculative voices took this further. Could repeated encounters, each leaving signs in the solar wind, accumulate into patterns? Could the heliosphere itself be marked by centuries of parasitic feeding, its plasma flows warped by countless faint echoes? If so, then the wind of the sun is not a steady stream, but a palimpsest, a layered record of every intruder that has fed upon it. In the end, the sun still breathes, vast and inexhaustible. Its wind continues to fill the solar system, shielding Earth and planets alike. Atlas is gone. It's feeding a whisper against the storm. But the signs remain in the data: compressed particles, twisted fields, wakes that drift outward into the void. To those who look closely, they are reminders that even the sun's breath can be disturbed, that even the simplest flows of energy can carry the scars of parasites. And so we are left with this haunting thought: the solar wind is not just a river of particles, but a canvas of memory. It carries with it the history of feeding, the faint imprints of hunger, the quiet signs of a star that has been touched. And so, as 3i divided by Atlas drifts farther from the sun, the brightness dims, the coma thins, and the data taper off into silence. We are left not with closure, but with questions that remind us how much of the cosmos remains uncharted. The idea of a cosmic parasite may be metaphor more than mechanism, yet it captures the unease and awe that such an object inspires. Was it feeding? Was it fragmenting? Or was it only reflecting the long memory of ancient ice? Tonight, we set the questions down gently. The stars remain, steady in their courses, and the sun still rises. Somewhere beyond, another fragment of another world is already on its way. Until then, let us rest in the mystery, quiet in the knowledge that the universe still holds secrets vast enough to humble us all.